This is the 6-5 and 7-7 review. Number 2, calculators are not allowed. And in this particular problem, we are trying to match a trapezoidal approximation with the associated definite integral. So in order to get here, we need to remember where this comes from. So we know that for any random function for which I want to do a trapezoidal approximation, we can think about 1/2 the height, which is going to be my delta x, or my b minus a over n, times the first leg, or the first base, and then we double all of the interior bases. And remember, each interior base we're going to add another delta x into the input for f, and we'll continue that out to our next to last interior base, and then we get a single base on each edge. So what we're going to be looking for is this number out in front should be a 1/2 b minus a, and this number should be the function with the a plugged in. So if I have an a and I plug it in here, I should get this number, and if I plug the b into here, I should get this back number. So if we look first, plugging a 0 into here, I should get a root 2, and the only one that has a root 2 is d. So if I look at my upper one, plug the 2 in, that's going to give me a 4 plus a 2, which is a root 6. We can see that the last piece matches. So far it's looking like D is going to go with Roman numeral 1. The last thing we would check is what's inside here. So we need that 1/4 to be, so let me just put this down here, Roman numeral 1. We need that 1/4, which is the number out in front, to be 1/2 the b minus the a over the n. So in order to figure out the n, we need to count how many trapezoids there are. So this one plus one of these becomes my first trapezoid. So I have 1 trapezoid, 2 trapezoids, 3 trapezoids, 4 trapezoids. So if I put my n is 4 down here and multiply this all out, I see that indeed I get 1/4. So that means I is going to match with D. So let's look at Roman numeral 2. If I look at Roman numeral 2, I can plug the 2 in, that gives me a root 1. So that narrows me down to the A and B. If I plug a 4 in, I get a root 3. So that already narrows me down to this one here. So to double check, let's look at that front number 1/4. That front number, which is a 4th, should be a 1/2 of b minus an a over an n. So the n is how many trapezoids I've got. So there's 1, 2, 3, 4. So notice I still get a 4th, and it works. So Roman numeral 2 is going to work with B. If I look at Roman numeral 3, again, I'm going to plug my a and b in to see what happens. Plug in my a, I get a 4 minus 3 is a root 1. So that narrows us down to A, and then I plug the 4 in, that gives me a 16 minus a 3 gives me a root 13. Let's double check the front. If I look at 3, that 1/6 should be a 1/2 b minus a over n. And in this case I have 1, 2, 3, 4, 5, 6 of these. And what do you know? It comes out as 1/6. So the third one works with A. Last but not least, let's look at 4. If I plug 3 in, I get a root 4. There's my root 4. If I plug a 5 in, I get a root 6. There's my root 6. And then if I double check the number in front, 1/6 needs to be 1/2 the b minus the a over the number of subintervals, or the number of trapezoids. So 1, 2, 3, 4, 5, 6. I end up with 1/6. So C is the one that matches with 4. Darn it. let's look at all these. You can see I have my b minus a, b minus a, b minus a, b minus a, and then I am dividing by those number of trapezoids and verifying that the number in front is indeed what it should be.